Today's exceptionally awesome episode is made possible through the support of Paul Plusa and dozens of people on Patreon just like you. Please check out the links below in the description and see how you can get involved and help me make more and better videos and get to see some really cool secret stuff for you in the process. Thank you. Hi there guys, I'm Chris Boden and welcome back to The Bench for Electronics, Episode 8. Today, we're doing this. I got a clock kit and I'm feeling pretty good about myself. And I'm going to tell you why. And this isn't like that whole I'm feeling pretty good about myself and you should come feel me too. No, this is cool because I got looking up this kit. Now, I want to explain that I bought this kit like super cheap. So, like most of these little electronic kits that I'm doing in this whole like me learning the basics series are really, really, really cheap. And I just recently got into learning about the Amazon affiliate link thing. And that's pretty cool. Like, I like the idea that if I find something that I think is skookum and I can be like, hey, this doesn't suck. You should check this out. And I can make like 4% or something. It's not a lot, but like it's like 4% on stuff. And that's cool. Like if you click the link in the description and you buy a thing, then I get to make a couple bucks and it doesn't cost you anything and cool. It hadn't occurred to me that, because I had a lot of trepidation about getting into that, because I'm like, I don't want to be that guy. I don't want to be like, hey, you should buy this fucking thing and it's cool. Because like these are cheap Chinese shit. Like ain't no bones about it. These are cheap Chinese shit, but they're fun and you get to learn stuff and that's cool. So I got looking into the instructions for this because there pretty much are no fucking instructions for this that come with it. There's like a QR code bullshit and so I Googled it and I came up with a couple videos. And there are other videos of people making this exact kit on YouTube, which would make sense. I mean, I thought I was your person. But I watched them, and one was this cool, it's like Grandpa is an Old Man or something like that was like the name of the dude. Super cool. Like, Grandpa's gonna fucking build a kit with you, and that's neat. And it was like the electronics version of watching Steady Craftsman, who is the creepiest dude on the internet, in case you're wondering. And I fell into one that this guy, the whole video is like 10 minutes long. You can't do this in 10 minutes. Okay. I can't do this in 10 minutes, and I'm pretty sure fucking Sparky couldn't do this in 10 minutes, and he's forgotten more how to solder than I'll ever know. But this dude is just like, he's not teaching you anything. His soldering is worse than mine in episode 1, and that, like, I hadn't realized that I'd actually learned how to solder worth a damn, but turns out I have, because I've seen his, and it was like, whoa! And just, fuck! And he's just shilling shit, and he's not teaching anything. And if you're gonna make a video that's like, here's how to do a thing, you should fucking teach people stuff. So it just bugged me. It just made me feel dirty. And I'm like, I know exactly what I don't want to become. So I will put the link for this in the description. If you want to buy one, do it. If you don't, fuck it. They're like $12. There's no reason to shill this. They're only $12 kits. What's 4% of $12. Can you do the math on that? Because I can tell you what it is. Not much. Not worth trying to be like, hey, you should buy these fucking kits. No, fuck man, it's $12. You decide for yourself if you think you want to buy one. I don't give a shit. So here's what we got. We got a board. We're gonna build. It's called a 4-bit electronic clock, and there really isn't a lot to it. But there's a couple things on here that I'm not familiar with, and I went looking for the instructions, but I couldn't find shit. So I don't know how well this is going to go. I got one question on here because I got 3 capacitors. And let's get a look. Something to point out. When I show stuff on the camera, you guys can see this way better than I can because I got like shit blocking my view. I got to lean over the fucking thing. And when I look down at that, it's that big, okay? It's fucking tiny. So when I'm holding it down there, I'm holding this like this far away. You try to hold a capacitor and read it that fucking far away because I can't see a goddamn thing. So I've had people comment like, man, you can't see worth shit. I was like, well, you should try this. Yeah, I can't I can see that there's writing on there. Like even if I'm looking at the camera, that's blank. What does that say? 10 fuck, I don't know. That's what it says. And that's zoomed in all the way. I got nothing. Let's try it on, maybe I can get something on this camera. Yeah, you got shit and shoved in it. I got no joy. Okay, so we don't know what the hell that is, but it's bigger than the other two. So we know that. So this has a little black dot on top, which is cool. And that says 30. Okay, 30. So that's a 30. And that's a 30. Okay, so I got two that are the same and one that's different. That's going to be our piezo. Remove seal after washing. Boop. So the reason they put this on here is for if you do like commercial for serious soldering, they have machines. It's really fucking cool to see. It's called like wave soldering or wave flow soldering or something. I've only seen a little bit of it, but man, it's cool to see. So we got a capacitor here that's 25 volts, 10 microfarads. Okay. So we got one big cap. We got two switches. Those are easy. We got a chip and a socket, and our chip is that. I'm guessing this is a really basic 4-bit microprocessor of some sort. We got one of these. Now I've heard about these, but I've never messed with one before. This is, it's called a resistor pack or a resistor strip or a modular resistor. And I think what this is a bunch of resistors in series. It may be one big resistor that's just tapped off, which electrically, wouldn't that be the same thing? I think it would. But I think this is a bunch of resistors in series. I don't really know a lot about these, and I'm just starting to learn about this stuff. But I think that's a bunch of resistors in series, all in one module. And I think it's cool that that exists, but I'm not entirely sure why that exists. Like, who came up with the idea is like, you know what we need? We need a fuckload of resistors all in a row, and we need this a lot. We need this often enough that we're going to build a component around it and make a whole factory that makes them. So this is a little power plug. That's easy. Barrel connector. This is fucking tiny. Delta 331. The top is Sierra Bravo. Is that? Man. Can you see how small my fingerprints are here? Or how big my fingerprints are? That's how tiny that is. I'm going to say Sierra Hotel 550 maybe, and the bottom is Delta 331. So, transistor? Looks like a transistor, but I learned yesterday those can be voltage regulators too. It just comes in a package. And then we got a couple resistors that are brown, black, red with a gold stripe. Now, hang on, shit. I know this. Well, I have it on the thing. Brown, black, red with a gold stripe is 1K. So these are 1K resistors. And then we've got this one I at least know right off the top of my head. This is a quartz crystal. And this is one of those things that, this exists. Somebody has a factory that makes these. Blows my mind. That is a quartz crystal in a little metal can that oscillates 12 million times a second. That's 12 megahertz. Wait, that's 12,000. Is that 12 kilohertz? I think it's 12 megahertz, and it's 12.000 megahertz is what I think. I could be wrong on this. That might be a 12 kilohertz clock, but that seems way low for a quartz crystal. So I'm going to say that's a 12 megahertz crystal. And if you want to see an amazing bit of video, There is a video, it's on YouTube, it's not hard to find. Somebody please post it in the comments because we should share this with people. There's a video from like World War II era where they're making quartz crystals for military applications, probably something to do with radios and stuff. But they show the whole process of how they do it, and it's like, it's pretty much all women, and they like have to examine the crystal and they cleave it, and there's a lot of steps of washing and polishing and cutting, and it's so cool. And it's all rocks. It's fucking rocks. It's chunks of quartz, and they have to cut it on certain angles and make it do a thing, and then a person tests it, and then they gotta like fuck with it a little bit, and they test it again, they get it just, and it's a whole thing. And the fact that there's a factory today that makes these, and they probably cost pennies a piece. Like, look up what a 12 megahertz quartz crystal costs on like DigiKey. It's nothing. The fact that we can do this blows my mind. Just the manufacturing processes, the manufacturing and engineering that goes into that blows my mind. So I'm looking at my board here. Oh my God, it's got values on it. It doesn't just say R1, R2. It tells us stuff. I think that's all the instructions we need. I think we're going to be okay. I think we can fucking build this. I'm going to try. I'm firing. My soldering iron's already warmed up because it operates at the speed of fucking light. So, oh, and we've got this cable here that's USB cable. So I'm going to do this without any instructions because I tried looking them up and I couldn't really get anywhere because I'm here teaching science and technology and I still can't make QR codes work worth a shit on my phone. So we're just going to jump into this. We're going to do this thing. I don't know if it's going to work. Might completely eat shit, but we're going to give it a shot. I got my flux pen. I got my soldering iron. I'm shaking this up because it's full. And when I shake it up, it smells like alcohol, which tells me a fucking thing leaks. Expired date. They expire? 6/20/21. I'm going to use the fuck out of this before it expires, so I'm not going to worry about that. All right, let's do this thing. I'm gonna move all my parts out the way. Grab my little stand. Slide that way down because we're working up front. All right, you guys ready to do this? Are you motivated? We're 12 minutes in. We haven't done a fucking thing yet, so it's about time. I'm going to start with the resistors because all the kits start with the resistors, and I got to think there's a reason for that. So we're going to put in our big bar resistor block thing. Now there's a little mark at this end. So this is Pri1K, PR1 parallel resistor? No, because it'd be series. Why is it called P? I don't know. What's the P in PR? The R is probably resistor. So let's look at this. There's a label, there's a dot and a label. Fuck. And there's nothing on the back. So I'm going to say it goes in this way, with the dot towards the thing. Now understand, I'm not 100% on this. I may be leading you wrong. It can happen. I'm going to solder, or I'm going to flux the fuck out of that first. I think the dot goes in the little square because I think I don't know, would those have polarity? It's a resistor. But this is a bunch of resistors in a row. So, like, they took the time to mark it, which indicates that there's a reason. So I'm putting the dot end, the label side front, and the dot end at that end. Because it doesn't have a notch or anything, but it's got a dot printed on it. It doesn't have a stripe on it. You'd think they put a stripe on it like capacitors. So I'm going to just clamp this down in the middle at a random point and just solder the shit out of it. Oh, that's a lot of ugly. Let's do that thing, that cool. I love this thing. This is so cool. Watch this. Ooh, yeah. And polish my tip. Oh, that's sexy. You can't be cramming your dirty gungy tip into freshly clean tight little holes. That's just not polite. So coming in. Okay, that's all right. I'm going to do this end. Okay, now see that's a decent joint. Now I can take my clamp off. So Sparky commented and said the resistor must go the right way around. The dot is the common wire. Okay, so they're not all just in series. So that's why it matters. The dot's a common. So if the dot's a common, does that mean it's a bunch of resistors that are all in parallel? Because if they're all in parallel, that makes sense why they call it PR1, because it's a parallel resistor. Heat up. Put a little dot of solder on my tip there. I'm having thermal conductivity issues. Oh yeah, that fixed it. Boom! God, that's sexy. Look at that. Look at that joint. They're uniform. They're clean. Oh man, I'm proud of myself on that. And so should you. If you're at the point where you can solder that good, you should be proud, because it took me some work to get there. Okay, what's next? Let's do that. I'm just going to work my way down. So over here, we can see we need a 10 microfarad capacitor. And right here, and this is cool because we're figuring this out from contextual clues, and I like that. So that's 10 microfarads. Now we see this is the short side, and it's marked negative. And they labeled it very clearly, positive and negative. Boom. I'm just going to spread that a bit to hold it. Clean my tip, grab my shit, oh wait, we gotta flux it. I always forget the flux. Like that's my recurring failure, is I forget to flux. Get on the thing. There you go. That looks all right. I got a little tracking up there, but we'll just cut that off. That's a little shitty, but I'm going to live with it. Okay, so next thing along the top here is Q1. Now it's the only thing I see that has that package shape. So that's where my transistor goes. And the great and powerful Sparky assures me that the Bravo Delta 331 is an NPN transistor. And if Sparky says it, I believe it, and that settles it. You just line that up and drop it right in there. That's lovely. Flip it right the way around, flux it. I really should flux first. It feels better when I flux it first, but it doesn't really matter. How's that look? That look all right to you? What do you think? I think it's good. Okay. Okay, I'm going to do the 10K resistor, which we identified. 10K is brown, black, red is 10,000 ohms. We're going to put that right there. Oh, that's tight. Get in your hole. The holes on this are smaller than on the velluming kits. And we've got the other 10K on the other side. I'm going to do them both at the same time. And because I got nothing but love from my OCD peeps, I'm going to make sure that they both point the same direction. Okay, so those are both in and down and good. Let's flip that over. So I've learned that these like thicker wires. So the little tiny stuff like this, that's why I was having some troubles on occasion. Because these like thicker wires. And now you know. Oh, clean my tip. Okay. All right, that's resistors are good. I'm happy. All right, let's do that big ass chip socket right in the middle. Yep. Because there's a lot to it. I'm going to use my little chip pin alignment jig, because you can use that on the sockets too. Now, if we look on the board, we can see there's a notch off to the end. And this also has a notch. So we just tab A, slot B. Nothing to it. So the circuit board on this is a very distinctive color. See how it's like that greenish, tannish color? That means it's made out of G10, which is an awesome and wonderful material that you should learn and love. G10 is really useful in the high voltage world for making any kind of structural components. Like if you need to stand up your secondary or your primary coil and stuff like that, you can make all kinds of stuff out of G10. It's not stupid expensive, but it's not cheap. Like when you get into buying commercial plastics, shit gets expensive fast. But it's a magnificent insulator and it's very, very strong. A lot of people have built, including me, have built spark gap rotors out of it. And the downside is it's hell to machine, in that it's stupid abrasive. Like, cuts like butter, nothing too cutting it, but you bring your carbide and your checkbook because you're going to go through a lot of bits cutting it. So this is just a socket, so we don't have to really worry about overheating it. We do got to get our tip clean. God. Ah. All right. But it's good to be in the habit of bouncing around corner to corner, end to end. So I've got the opposite corners attached. Now I can get that out of the way. And I'm just going to bounce around, because what I don't want to do is, with a component, put too much heat into any one spot. So you bounce around from one end of the device to the other. And it doesn't really matter where you go. Just Just spread it out. I'm having a lot of trouble trying to see this damn thing, just because of the angle I'm at. But you guys can see it good, which is the best combination, because I can't see what the fuck I'm doing, but you can. So I can screw it up really good, and you'll get some good entertainment out of it. And that's what I'm here for. I love that sound of flux. Tells me I did it right. Okay, how's it look? Ooh, yeah, that's... Oh, I forgot one. Shit! Shit, I missed one. Do you see it? I don't think I missed it. I think I just fucked it up. Where is that? Right there. That better? That's better. You think? Does it look all right? You got to take the time as you go through and do this and check your work as you go. Okay, so now we've got C4 104. Well, I remember this one had a 10, I'm going to say that's a 104. I'll put that in there. Now, I don't see it being marked for polarity, which it shouldn't be because it's a ceramic disc capacitor. And those are polarity agnostic, they don't care. Let's flux it. Beautiful. I'm very happy with that. One of the skills I'm learning in doing this is that what looks good to me when I see it here just staring at it is different than what looks good on camera when I look up here at the monitor and I'm trying to learn what looks good. And it's definitely helping me get better at soldering. All right, so we're gonna have, I got 2 caps left, but I only see one spot. Oh no, down there. There's a little one right there, and there's a little one right there, and they're both 30Ps, and I got a little 30, so I gotta think 30P is 30 picofarads, which is really tiny. I'm used to the Tesla coil world where I can get 30 picofarads just in a run of wire. I think that's easy. All right, so we've got our 2 little caps. Flip that around, spread these out a bit. The wires on these are super tiny, just hair thin. Okay. Cool. Now, if I'm doing this and you're watching on a live stream, because several of you are, and that's cool, I appreciate that, and you see me do something stupid and screw something up, comment right away, because I do pay attention to it, and you might save me a big screw up, and it's totally okay to call me out and be like, hey, dumbass, you fucked it. So now I'm going to put, this is our our 12 megahertz oscillator and drop that snugly down in there. This has much beefier leads on it than those little toy caps. And you got to realize they're selling these for like 12 bucks. So it's not going to have super high-end mil-spec componentry on it. Like you can't expect too much. So if I bitch about, you know, the tiny little leads on the capacitor, it's because somebody paid a fraction of a penny a piece for those capacitors and bought a fucking billion of them, and they're selling their kits. And that's all right. This isn't like audiophile grade shit, you know? Well, it's not audiophile grade shit unless you're used to buying like Monster brand stuff. Thumbs up for Monster hate. Okay, so now we got our clock counting, quartz chip in there. Every now and then I just brain fart completely, which is great when it happens on camera. You're just, okay. Look at that. I love how that works. Okay, so we got our little notch in the right end, and I'm going to put this in here. Squeeze it till it clicks. Yeah, that's all down. That's good. That's all right. You see that? It isn't quite flat on the board. I don't know why. I guess I just didn't clamp it as good as I should have. Like electrically it's fine. It just lives on a hill now. Okay, so that's in. And what's left? We got the piezo, the 2 switches, and the connector, and that's it. So, all right, so let's do the piezo next. One side of this is positive. Oh, hey, that's how we tell. One of the leads is longer. The longer lead is the positive lead. Okay, cool. So the piezo is in. Clamp it down. Spin it around. Fuck me. Okay, let's try that again. Positive's long. Thing's in. And I'm going to use my little clipper thing to bend that over, and now it'll stay there. And now I'll put my clamp on it, and we're going to solder that after we flux it, of course. And then I'll take the clamp off and do the other side. So serious electronics people that solder on the regular, how often, if you have the little pillow thing, the aloof loofah, how often do you got to turn yours around or fluff it? Because mine gets all like gunged down in there. Because maybe I'm just doing it wrong. Maybe you're not supposed to stab the shit out of it to clean your tip, but that's how I do it. I just stab my thing right in there. It's entirely possible I'm doing it wrong. But I like mine fluffy. All right, now I think we're on to the switches. Yeah, just the switches and the connector. So I'm just gonna carpet bomb flux the whole area. Because why not? And because we can just drop the switches right in. I love the switches and how they have the little bendy legs. Like that makes it so much easier to solder. I absolutely love these. And I don't know why they don't do this on all kinds of other componentry too. Like, why wouldn't you? Yeah, there's like a little bit of an extra step in manufacturing, but it's not that big a deal. And clearly the technology exists and we're doing it for millions and millions of parts. Why aren't we doing it for the majority of parts? Because we should. We could do better and we're choosing not to, and that makes me sad. So there's 5 things on here for soldering it, but these 2 are plastic. So I would recommend against soldering the plastic ones. Because yes, I'll bet it would melt on there and make a good connection. Oh no, look. The plastic pins go through these holes. Oh, what the fuck are those pins? There's holes there and they don't do nothing. I don't know what the hell. But I'm not going to solder them. I got concerns. All right, so let's do this. Look at that tip. Look at how fucking clean that tip is. I'm finally starting to learn this shit. Okay. Look at how much solder is pooled on that tip and not going on the board. Because I am clearly doing something wrong, but that's okay because I can get rid of some of that solder on the next one. Ah, fuck. Get in there. Okay. Now we just got this. I clean off my tip here a little bit. Now we just got this little 3-pack thing. I know why the switch leads are a little different to solder. They're so much bigger. They have more thermal mass, and it takes me a little bit longer for them to get up to temperature. When you solder bigger conductors, it takes longer for them to get hot. All right, so I think that's everything on the board. We're good there. The next thing is the big-ass display. So let's flux it. Okay. Now I'm going to slide this. I'm going to take it out and reposition it up higher with love and care. And now, so the pins are the same top and bottom, but this has a slight slant to it, and so does this, so I think it's pretty obvious that's the way that should go. I could be doing it wrong. It happens. I gotta take this right out to be able to see that damn thing. Okay, so, because my little alignment rig, oh, that's my problem. I had a pin that was way the hell out. This is surprisingly hard to do to get the fucking things in the hole. Because you can't see it. There's a whole row of pins down here. Okay, I got the top ones. But the bottom ones are kind of a bitch. Oh, this is hard. Okay, I'm gonna bend them. I'm gonna bend these out just a little bit. And that. All right, I got the bottom. I got the bottom. And then the top should be easier. Okay, we're binding on, pin 2. All right, that was an adventure. I'm gonna clamp that right down the middle because I don't want that thing falling out. That was kind of a bitch. All right, we got our board clamped. We're back on camera. It's gonna be fine. Everything's gonna be fine. Just relax. So let's get our tack welds in. There. 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 And there. Okay, so we're good on our four corners. Let's look at that. We're sitting flat. Okay. I'm going to take that out. I'm going to grab it on this end. Put down the Bernie stick before you start fucking around with stuff. So I'm going to relax some tension on there because that's, oh, okay, I'm going to increase some tension on there because that's way limp. You don't want to be, like, we're almost to the end of the video. You don't want to be going limp before we get to the big finish. That'll just kill my YouTube ratings. Okay. So I think this is the last thing to solder. Got shit on my tip. You never really realize how much solder you use. Like, you don't really register that solder is something you're consuming as you do this until you have to reach over and pull the little thing out a little bit. And you're like, wow, I do go through solder. Not a lot. All right. Final visual inspection. Everything look good to you? Those are pretty uniform. Look at the uniformity of the... Fucking hell! Look at the uniformity of all those joints. Like, yeah, they're not perfect, but this is episode 8. Okay? You can do this. Look at just a little bit of practice. Look at how much better you can get at this. Isn't that cool? Like, we're not going to pay attention to this bullshit off at an angle. That never happened. That's swamp gas. Just nothing to see there. But look at the back side of the board, where the work is. Look at that. Oh my God. That is so cool. All right. So, at this point, we have a clock, right? So I happen to have a little USB power supply sitting right here. And I'm going to plug this into my little USB supply. The cable is garbage. All right, are you ready? Let's see if it works. Ha! Fuck! Clearly it doesn't work, it's the wrong time. It says it's 12:59 and it's actually 11:22. So I totally fucked it up. It's garbage. It's all ruined. Or maybe I just have to set the clock, which I have no idea how to do. But it beeps. So the beeper works. Oh shit. Whoa, fuck, what? So it works as a countdown timer too. And a count up timer. I don't know what the fuck we're doing. Okay, so there's a lot of features to this that I don't begin to understand. But it works, and that's cool. And now I got to program it, because I made a thing. I made it. It's the closest to a computer I've ever made in my life, like from scratch. Like this, it's processing, it's computing, it's doing shit, and we got to do it together, and that's really cool. So the fucking thing works, and I got to tell you, for $12, that's pretty badass. That's cool. I'm gonna trim the really long leads off the back of that before I forget, because those are looking like hell. So we're just gonna Mow them down en masse. There, just clean all that up. So that's your little 4-bit clock kit. Rock simple. There's really nothing to it. You can build this. And we did it without instructions. We figured it out. We used contextual clues and some things that we learned before to be able to solve problems on a thing today. We took what we knew and used it to figure out what we didn't. And that is the basis of science, which is pretty damn cool. So thank you everyone for hanging out today. And if you're interested in getting one of these, links are in the description. Links for all my crap's in the description. They're absolutely Amazon affiliate links. So yeah, there's no big deal. If you buy it, it kicks me a couple bucks, and I appreciate that because this is my full-time job. This is what I do for a living. This is a pretty cool job. So thank you. If you build one of these, let me know. I want pictures. I want to see your project. I would totally recommend this for, like, if you've got a kid or a grandkid, like 12-ish, 12 years old or better. Maybe younger. It's your kid. You decide. What's some burn scars from a soldering iron among friends? Scars build character. Thank you guys for hanging out. You have fun. And as always, we'll see you next time.